Good day everyone, here's our math challenge for today. And here's our question. Solve for the value of x given that 1 plus square root of 3 raised to x equals 2 raised to x, wherein x is a real number. Now, if you want to try this problem, you can pause this video. You have 20 seconds and timer starts now. Time's up. Now let's answer this question together. I provide two solutions to this question. The first one is using pure algebra, and the second one is by using trigonometry. So let's start our first solution using algebra. Now let's get our given equation. 1 plus square root of 3 raised to x equals 2 raised to x. Now, square root of 3 raised to x can be written as 3 raised to x raised to 1/2. And 3 raised to x raised to 1/2 can be written as 3 raised to 1/2 times x. Now at this point, we need to let x be equal to 2 times k. Now the question is, why do we choose 2k? The reason is to cancel out the rational exponent right here. So now, let x be equal to 2k. Now 1/2 times 2k, this is just k. And on the right hand side, 2 raised to 2k is simply equal to 4 raised to k. Now, let's focus on this 4 raised to k. This 4 can be written as 1 plus 3. So 1 plus 3 is just 4. Now, again, on the right hand side of this equation, we can use the binomial expansion. So if we have x plus y raised to n, it is equivalent to the summation of n choose k times x raised to n minus k times y minus k as k goes from 0 to n. Or it is equal to the summation of n choose k times x raised to k times y raised to n minus k as k goes from 0 to n. And if we expand this using the summation, this is equivalent to x plus y raised to n equals to n choose 0 times x raised to n times y raised to 0 plus n choose 1 times x raised to n minus 1 times y raised to 1 plus all the way until we reach n choose n times x raised to 0 times y raised to n. Now, using the binomial expansion on the right-hand side of our equation, this will give us 1 plus k choose 1 times 3 raised to 1 plus k choose 2 times 3 raised to 2 plus k choose 3 times 3 raised to 3 plus all the way up to k choose k minus 1 times 3 raised to k minus 1 plus 3 raised to k. Now let's focus on this result. And also take note that the left-hand side must be equal to the right-hand side. Therefore, these middle terms must be gone, or simply 0. And in order to do that, k must be equal to 1. If k equals to 1, the left-hand side is just 1 plus 3 raised to 1, and on the right-hand side, this is just 1 plus k choose 1 times 3 raised to 1. And both sides is just equal to 4. Therefore, k must be equal to 1. And since x equals to 2 times k, therefore x must be equal to 2 times 1. And 2 times 1 is just 2. Therefore, using algebra, we get that the value of x must be equal to 2. Now, let's move on to our second solution using trigonometry. So let's go back to our equation. 1 plus square root of 3 raised to x equals 2 raised to x. Now, square root of 3 raised to x can be written as square root of 3 raised to x. Now at this point, let's divide all terms with 2 raised to x. Now on the right hand side, 2 raised to x over 2 raised to x is just 1. And 1 can be written as 1 raised to x because we know that x is a real number. And at this point, we will use some laws of exponent. If we have a raised to n over b raised to n, it is equivalent to a over b raised to the power of n. Therefore, this 1 raised to x over 2 raised to x can be written as 1/2 raised to x, and the square root of 3 raised to x over 2 raised to x can be written as square root of 3 over 2 raised to the power of x. And now realize that this 1, square root of 3, and 2 can be the side length of a right triangle, special right triangle, which is 30, 60, 90 right triangle. So we have the legs 1 and square root of 3, and we have the hypotenuse equal to 2. Now, if we let this angle be equal to theta, we get that sine of theta must be equal to square root of 3 over 2. Also, cosine theta must be equal to 1/2. And now, recall the Pythagorean identity that says that if we have cosine squared theta plus sine squared theta, it must be equal to 1. Now, we know the value of sine theta. This is just square root of 3 over 2. And we also know the value of cosine theta. This is just 1/2. Now, notice that we have 1/2 raised to 2 plus square root of 3 over 2 raised to 2 must be equal to 1. Therefore, the only value for x that this is equal to 1 must be equal to 2. Therefore, using trigonometry, we get the same value for x, which is equal to 2. Therefore, the value of x in this equation, 1 plus square root of 3 raised to x equals 2 raised to x, must be equal to 2. And as always, we are done.